Java is a set of several computer software products and specifications from Oracle Corporation that provides a system for developing application software and deploying it in a cross-platform computing environment. Java is used in a wide variety of computing platforms from embedded devices and mobile phones on the low end, to enterprise servers and supercomputers on the high end. While less common, Java applets are sometimes used to provide improved and secure functions while browsing the World Wide Web on desktop computers. Writing in the Java programming language is the primary way to produce code that will be deployed as Java bytecode. There are, however, bytecode compilers available for other languages such as Ada, JavaScript, Python, and Ruby. Several new languages have been designed to run natively on the Java virtual machine, such as Scala, Clojure and Groovy. Java syntax borrows heavily from C and C++, but object-oriented features are modeled after Smalltalk and Objective-C. Java eliminates certain low-level constructs such as pointers and has a very simple memory model where every object is allocated on the heap and all variables of object types are references. Memory management is handled through integrated automatic garbage collection performed by the JVM. On November 13, 2006, Sun Microsystems made the bulk of its implementation of Java available under the GNU General Public License. Platform. The Java platform is the name for a bundle of related programs from Sun that allow for developing and running programs written in the Java programming language. The platform is not specific to any one processor or operating system, but rather an execution engine and a compiler with a set of libraries that are implemented for various hardware and operating systems so that Java programs can run identically on all of them. Java Card, a technology that allows small Java-based applications to be run securely on smart cards and similar small memory devices. Java ME specifies several different sets of libraries for devices with limited storage, display, and power capacities. Often used to develop applications for mobile devices, PDAs, TV set-top boxes, and printers. Java SE, for general-purpose use on desktop PCs, servers and similar devices. Java EE, Java SE plus various APIs useful for multi-tier client to server enterprise applications. The Java platform consists of several programs, each of which provides a portion of its overall capabilities. For example, the Java compiler, which converts Java source code into Java bytecode, is provided as part of the Java development kit. The Java runtime environment, complementing the JVM with a just-in-time compiler, converts intermediate bytecode into native machine code on the fly. An extensive set of libraries are also part of the Java platform. The essential components in the platform are the Java language compiler, the libraries, and the runtime environment in which Java intermediate bytecode executes according to the rules laid out in the virtual machine specification. Java Virtual Machine. The heart of the Java platform is the concept of a virtual machine that executes Java bytecode programs. This bytecode is the same no matter what hardware or operating system the program is running under. There is a JIT compiler within the Java Virtual Machine, or JVM. The JIT compiler translates the Java bytecode into native processor instructions at runtime and caches the native code in memory during execution. The use of bytecode as an intermediate language permits Java programs to run on any platform that has a virtual machine available. The use of a JIT compiler means that Java applications, after a short delay during loading and once they have warmed up by being all or mostly JIT compiled, tend to run about as fast as native programs. Since JRE version 1.2, Sun's JVM implementation has included a just-in-time compiler instead of an interpreter. Although Java programs are cross-platform or platform-independent, the code of the Java virtual machines that execute these programs is not. Every supported operating platform has its own JVM. Class libraries. In most modern operating systems, a large body of reusable code is provided to simplify the programmer's job. This code is typically provided as a set of dynamically loadable libraries that applications can call at runtime. Because the Java platform is not dependent on any specific operating system, applications cannot rely on any of the pre-existing OS libraries. Instead, the Java platform provides a comprehensive set of its own standard class libraries containing much of the same reusable functions commonly found in modern operating systems. Most of the system library is also written in Java. For instance, Swing library paints the user interface and handles the events itself, eliminating many subtle differences between how different platforms handle even similar components. The Java class libraries serve three purposes within the Java platform. First, like other standard code libraries, the Java libraries provide the programmer a well-known set of functions to perform common tasks, such as maintaining lists of items or performing complex string parsing. Second, the class libraries provide an abstract interface to tasks that would normally depend heavily on the hardware and operating system. Tasks such as network access and file access are often heavily intertwined with the distinctive implementations of each platform. The Java.NET and Java.io libraries implement an abstraction layer in native OS code, then provide a standard interface for the Java applications to perform those tasks. Finally, when some underlying platform does not support all of the features a Java application expects, the class libraries work to gracefully handle the absent components either by emulation to provide a substitute, or at least by providing a consistent way to check for the presence of a specific feature. Languages. The word Java, alone, usually refers to the Java programming language that was designed for use with the Java platform. Programming languages are typically outside of the scope of the phrase platform, although the Java programming language was listed as a core part of the Java platform before Java 7. The language and runtime were therefore commonly considered a single unit. However, an effort was made with the Java 7 specification to more clearly treat the Java language and the Java virtual machine as separate entities, so that they are no longer considered a single unit. Third parties have produced many compilers or interpreters that target the JVM. Some of these are for existing languages, while others are for extensions to the Java language. These include Bean Shell, a lightweight scripting language for Java; Clojure, a dialect of the Lisp programming language; Groovy, a dynamic language with features similar to those of Python, Ruby, Perl, and Smalltalk; JRuby, a Ruby interpreter; Python, a Python interpreter; Kotlin, an industrial programming language for JVM with full Java interoperability; Rhino, a JavaScript interpreter; Scala, a multi-paradigm programming language designed as a better Java; GOSU, a general-purpose Java virtual machine-based programming language released under the Apache License 2.0. Similar platforms. The success of Java and its write once, run anywhere concept has led to other similar efforts, notably the .NET framework, appearing since 2002, which incorporates many of the successful aspects of Java.NET in its complete form is currently only fully available on Windows platforms, whereas Java is fully available on many platforms. .NET was built from the ground up to support multiple programming languages, while the Java platform was initially built to support only the Java language, although many other languages have been made for JVM since. .NET includes a Java-like language called Visual J that is incompatible with the Java specification, and the associated class library mostly dates to the old JDK 1.1 version of the language. For these reasons, it is more a transitional language to switch from Java to the .NET platform, than a first-class .NET language. Visual J was discontinued with the release of Microsoft Visual Studio 2008. The existing version shipping with Visual Studio 2005 will be supported until 2015 as per the product lifecycle strategy. Java Development Kit. The Java Development Kit is a Sun product aimed at Java developers. Since the introduction of Java, it has been by far the most widely used Java software development kit. It contains a Java compiler, a full copy of the Java runtime environment, and many other important development tools. History. The Java platform and language began as an internal project at Sun Microsystems in December 1990, providing an alternative to the C++/C programming languages. engineer Patrick Norton had become increasingly frustrated with the state of Sun's C++ and C application programming interfaces and tools. While considering moving to Next, Norton was offered a chance to work on new technology, and thus the Stealth project was started. The Stealth project was soon renamed to the Green Project, with James Gosling and Mike Sheridan joining Norton. Together with other engineers, they began work in a small office on Sand Hill Road in Menlo Park, California. They were attempting to develop a new technology for programming next-generation smart appliances, which Sun expected to be a major new opportunity. The team originally considered using C++, but it was rejected for several reasons. Because they were developing an embedded system with limited resources, they decided that C++ needed too much memory and that its complexity led to developer errors. The language's lack of garbage collection meant that programmers had to manually manage system memory, a challenging and error-prone task. The team was also troubled by the language's lack of portable facilities for security, distributed programming, and threading. Finally, they wanted a platform that could be easily ported to all types of devices. Bill Joy had envisioned a new language combining Mesa and C. In a paper called Further, he proposed to Sun that its engineers should produce an object-oriented environment based on C++. Initially, Gosling attempted to modify and extend C++ but soon abandoned that in favor of creating a new language, which he called Oak, after the tree that stood just outside his office. By the summer of 1992, they were able to demonstrate portions of the new platform, including the Green OS, the Oak language, the libraries, and the hardware. Their first attempt, demonstrated on September 3, 1992, focused on building a personal digital assistant device named Star 7, 2, that had a graphical interface and a smart agent called Duke to assist the user. In November of that year, the Green Project was spun off to become FirstPerson, a wholly owned subsidiary of Sun Microsystems, and the team relocated to Palo Alto, California. The FirstPerson team was interested in building highly interactive devices, and when Time Warner issued a request for proposal for a set-top box, FirstPerson changed their target and responded with a proposal for a set-top box platform. However, the cable industry felt that their platform gave too much control to the user, and FirstPerson lost their bid to SGI. An additional deal with the 3Do company for a set-top box also failed to materialize. Unable to generate interest within the TV industry, the company was rolled back into Sun, Java Meets the Web, in June and July 1994, after 3 days of brainstorming with John Gage, the director of science for Sun, Gosling, Joy, Norton, Wayne Rosing, and Eric Schmidt. The team retargeted the platform for the World Wide Web. They felt that with the advent of graphical web browsers like Mosaic, the Internet could evolve into the same highly interactive medium that they had envisioned for cable TV. As a prototype, Norton wrote a small browser, WebRunner, renamed HotJava in 1995. In 1994, Sun renamed the Oak language as Java after a trademark search revealed that Oak technology used the name Oak. Although Java 1.0 became available for download in 1994, the first public release of Java, Java 1.0A2 with the HotJava browser, came on May 23, 1995, announced by Gage at the Sun World Conference. Accompanying Gage's announcement, Mark Andreessen, Executive Vice President of Netscape Communications Corporation, unexpectedly announced that Netscape browsers would include Java support. On January 9, 1996, Sun Microsystems formed the JavaSoft group to develop the technology. Version history. The Java language has undergone several changes since JDK 1.0 was released on, as well as numerous additions of classes and packages to the standard library. Since J2SE 1.4, the evolution of the Java language has been governed by the Java Community Process, which uses Java specification requests to propose and specify additions and changes to the Java platform. The language is specified by the Java Language Specification. Changes to the JLS are managed under JS 901. JDK 1.1 was released on February 19, 1997. Major additions included an extensive retooling of the AWT event model, inner classes added to the language, Java bins and JDBC, J2SE 1.2 a Euro codename Playground. This and subsequent releases through J2SE 5.0 were rebranded Java 2 and the version name J2SE replaced JDK to distinguish the base platform from J2E and J2ME. Major additions included Reflection, a collections framework, Java IDL, and the integration of the Swing graphical API into the core classes. A Java plugin was released, and Sun's JVM was equipped with a JIT compiler for the first time. J2SE 1.3 a Euro codename Kestrel. Notable changes included the bundling of the hotspot JVM, Java Sound, Java naming and directory interface and Java platform debugger architecture, J2SE 1.4 a Euro codename Merlin. This was the first release of the Java platform developed under the Java Community Processes JS of 59. Major changes included regular expressions modeled after Perl, exception chaining, an integrated XML parser and XSLT processor, and Java Web Start. J2SE 5.0 a Euro codename Tiger. Originally numbered 1.5, which is still used as the internal version number. Developed under JS 176, Tiger added several significant new language features including the for each loop, generics, autoboxing and var args. Java SE6 a Euro codename Mustang. Bundled with a database manager and facilitates the use of scripting languages with the JVM. As of this version, Sun replaced the name J2SE with Java SE and dropped the .0 from the version number. Other major changes include support for pluggable annotations, many GUI improvements, including native UI enhancements to support the look and feel of Windows Vista, and improvements to the Java platform debugger architecture and JVM tool interface for better monitoring and troubleshooting. Java SE7 a Euro codename Dolphin. This version was developed under JS of 336. It added many small language changes including strings in switch, try with resources and type inference for generic instance creation. The JVM was extended with support for dynamic languages, while the class library was extended among others with a join fork framework, an improved new file I/O library and support for new network protocols such as SCTP. Java 7 Update 55 was released to the public on April 15, 2014. The current version, Java SE8, no longer officially supports the Windows XP platform, though unofficial methods are possible to make it run on Windows XP SP22. In addition to the language changes, much more dramatic changes have been made to the Java class library over the years, which has grown from a few hundred classes in JDK 1.0 to over 3,000 in J2SE 5.0. Entire new APIs, such as Swing and Java 2D, have been introduced, and many of the original JDK 1.0 classes and methods have been deprecated. Usage, desktop use. According to Oracle, the Java runtime environment is found on over 850 million PCs. Microsoft has not bundled a Java runtime environment with its operating systems since Sun Microsystems sued Microsoft for adding Windows-specific classes to the bundled Java runtime environment, and for making the new classes available through Visual J++. Apple no longer includes a Java runtime with OS X as of version 10.7, but the system prompts the user to download and install it the first time an application requiring the JRE is launched. Many Linux distributions include the partially compatible free software package GNU Class Path and increasingly mostly compatible ICE-T. Some Java applications are in fairly widespread desktop use, including the NetBeans and Eclipse integrated development environments, and file-sharing clients such as LimeWire and Vue. Java is also used in the MATLAB mathematics programming environment, both for rendering the user interface and as part of the core system. Java provides cross-platform user interface for some high-end collaborative applications like Lotus Notes. Mobile devices. Java ME has become popular in mobile devices, where it competes with Symbian, Brew, and the .NET Compact framework. the diversity of mobile phone manufacturers has led to a need for new unified standards so programs can run on phones from different suppliers, MIDP. The first standard was MIDP1, which assumed a small screen size, no access to audio, and a 32 kilobytes program limit. The more recent MIDP2 allows access to audio, and up to 64 kilobytes for the program size. With handset designs improving more rapidly than the standards, some manufacturers relax some limitations in the standards, for example, maximum program size. Google's Android operating system uses the Java language, but not its class libraries, therefore the Android platform cannot be called Java. Android executes the code on the Dalvik VM instead of the Java VM. Web server and enterprise use, the Java platform has become a mainstay of enterprise IT development since the introduction of the Enterprise Edition in 1998, in two different ways. Through the coupling of Java to the web server, the Java platform has become a leading platform for integrating the web with enterprise back-end systems. This has allowed companies to move part or all of their business to the Internet environment by way of highly interactive online environments that allow the customer direct access to the business processes. This trend has continued from its initial web-based start. The Java platform has matured into an enterprise integration role in which legacy systems are unlocked to the outside world through bridges built on the Java platform. This trend has been supported for Java platform support for EAI standards like messaging and web services and has fueled the inclusion of the Java platform as a development basis in such standards as SCA, XAM and others. Java has become the standard development platform for many companies' IT departments, which do most or all of their corporate development in Java. This type of development is usually related to company-specific tooling, and the choice for the Java platform is often driven by a desire to leverage the existing Java infrastructure to build highly intelligent and interconnected tools. The Java platform has become the main development platform for many software tools and platforms that are produced by third-party software groups and are used as configurable tools by companies. Examples in this category include web servers, application servers, databases, enterprise service buses, business process management tools and content management systems. Enterprise use of Java has also long been the main driver of open-source interest in the platform. This interest has inspired open-source communities to produce a large amount of software, including simple function libraries, development frameworks, and open-source implementations of standards and tools. Mascot. Duke is Java's mascot. When Sun announced that Java SE and Java ME would be released under a free software license, they released the Duke graphics under the FreeBSD license at the same time. A new Duke personality is created every year. For example, in July 2011 Future Tech Duke included a bigger nose, a jetpack, and blue wings. Licensing. The source code for Sun's implementations of Java has been available for some time, but until recently the license terms severely restricted what could be done with it without signing a contract with Sun. As such, these terms did not satisfy the requirements of either the Open Source Initiative or the Free Software Foundation to be considered open source or free software. Sun Java was therefore a proprietary platform. While several third-party projects created free software partial Java implementations, the large size of the Sun libraries combined with the use of clean room methods meant that their implementations of the Java libraries were incomplete and not fully compatible. These implementations also tend to be far less optimized than Sun's. Free software. Sun announced in Java 1 2006 that Java would become free and open source software, and on October 25, 2006, at the Oracle Open World Conference, Jonathan I. Schwartz said that the company was set to announce the release of the core Java platform as free and open source software within 30 to 60 days. Sun released the Java Hotspot virtual machine and compiler as free software under the GNU General Public License on November 13, 2006, with a promise that the rest of the JDK would be placed under the GPL by March 2007. According to Richard Stallman, this would mean an end to the Java trap. Mark Shuttleworth called the initial press announcement a real milestone for the free software community. Sun released the source code of the class library under GPL on May 8, 2007, except some limited parts that were licensed by Sun from third parties who did not want their code to be released under a free software and open source license. Some of the encumbered parts turned out to be fairly key parts of the platform, such as font rendering and 2D rasterizing, but these were released as open source later by Sun. Sun's goal was to replace the parts that remain proprietary and closed source with alternative implementations and make the class library completely free and open source. In the meantime, a third-party project called Ice-T created a completely free and highly usable JDK by replacing encumbered code with either stubs or code from GNU ClassPath. Although OpenJDK has since become buildable without the encumbered parts, Ice-T is still used by the majority of distributions, such as Fedora, RHEL, Debian, Ubuntu, Gentoo, Arch Linux and Slackware, as it provides security releases and an easier means for patch inclusion. OpenJDK also still doesn't include a browser plugin and WebStart implementation, so Ice-T's companion project, Ice-T Web, is needed to fill this gap. In June 2008, it was announced that Ice-T 6 has passed the technology compatibility kit tests and can claim to be a fully compatible Java 6 implementation. Because OpenJDK is under the GPL, it is possible to redistribute a custom version of the JRE directly with software applications, 3.4, rather than requiring the end user to download and install the correct version of the proprietary Oracle JRE onto each of their systems themselves. Criticism. Generics. When generics were added to Java 5.0, there was already a large framework of classes, so generics were chosen to be implemented using Erasure to allow for migration compatibility and reuse of these existing classes. This limited the features that could be provided by this addition as compared to some other languages. Unsigned integer types. Java lacks native unsigned integer types. Unsigned data are often generated from programs written in C, and the lack of these types prevents direct data interchange between C and Java. Unsigned large numbers are also used in many numeric processing fields, including cryptography, which can make Java less convenient to use for these tasks. Although it is possible to partially circumvent this problem with conversion code and using larger data types, it makes using Java cumbersome for handling the unsigned data. While a 32-bit signed integer may be used to hold a 16-bit unsigned value with relative ease, a 32-bit unsigned value would require a 64-bit signed integer. Additionally, a 64-bit unsigned value cannot be stored using any integer type in Java because no type larger than 64 bits exists in the Java language. If abstracted using functions, function calls become necessary for many operations which are native to some other languages. Alternatively, it is possible to use Java's signed integers to emulate unsigned integers of the same size, but this requires detailed knowledge of complex byte-wise operations. Floating-point arithmetic. While Java's floating-point arithmetic is largely based on IEEE 754, certain features are not supported even when using the strict modifier, such as exception flags and directed roundings are Euro capabilities mandated by IEEE Standard 754. Additionally, the extended precision floating-point types permitted in 754 and present in many processors are not permitted in Java. Performance. In the early days of Java there were some criticisms of performance. However, benchmarks typically report Java as being about 2 times slower than C. Java's performance has improved substantially since the early versions. Performance of JIT compilers relative to native compilers has in some optimized tests been shown to be quite similar. Java bytecode can either be interpreted at runtime by a virtual machine, or it can be compiled at load time or runtime into native code which runs directly on the computer's hardware. Interpretation is slower than native execution, and compilation at load time or runtime has an initial performance penalty for the compilation. Modern performance JVM implementations all use the compilation approach, so after the initial startup time the performance is equivalent to native code. Security. The Java platform provides a security architecture which is designed to allow the user to run untrusted bytecode in a sandboxed manner to protect against malicious or poorly written software. This sandboxing feature is intended to protect the user by restricting access to certain platform features and APIs which could be exploited by malware, such as accessing the local file system, running arbitrary commands, or accessing communication networks. In recent years, researchers have discovered numerous security flaws in some widely used Java implementations, including Oracle's, which allow untrusted code to bypass the sandboxing mechanism, exposing users to malicious attacks. These flaws affect only Java applications which execute arbitrary untrusted bytecode, such as web browser plugins that run Java applets downloaded from public websites. Applications where the user trusts, and has full control over, all code that is being executed are unaffected. On August 31, 2012, Java 6 and 7 on Microsoft Windows, Mac OS X, and Linux were found to have a serious security flaw that allowed a remote exploit to take place by simply loading a malicious web page. Java 5 was later found to be flawed as well. On January 10, 2013, 3 computer specialists spoke out against Java, telling Reuters that it was not secure and that people should disable Java. Jaime Blasco, labs manager with Alien Vault Labs, stated that Java is a mess. ET unregistered trademark S not secure. You have to disable it. This vulnerability affects Java 7 and it is unclear if it affects Java 6, so it is suggested that consumers disable it. Security alerts from Oracle announced schedules of critical security-related patches to Java. On January 14, 2013, security experts said that the update still failed to protect PCs from attack. This exploit hole prompted a response from the United States Department of Homeland Security encouraging users to disable or uninstall Java. Apple blacklisted Java in limited order for all computers running its Mac OS X operating system through a virus protection program. Adware, the Java browser runtime environment has a history of bundling sponsored software, including the ask.com toolbar, and McAfee Security Scan Plus in its updater. Redundancy, several authors in line with recent Java security and vulnerability issues have called for users to ditch Java. Once promising, it has outlived its usefulness in the browser, and has become a nightmare that delights cybercriminals at the expense of computer users. I think everyone should uninstall Java from all their PCs and Macs, and then think carefully about whether they need to add it back. If you are a typical home user, you can probably do without it. If you are a business user, you may not have a choice. See also: Java version history, common intermediate language, comparison of the Java and .NET platforms, criticism of Java, list of Java APIs, Java logging frameworks, Java performance, JavaFX, Giselle, references. External links. Official website, sun.com, official developer site, infoc.com, presentation by James Gosling about the origins of Java, from the JVM Languages Summit 2008. Java Tutorials and Examples Collection, 5, javatester.org, what version of Java are you using? Tells you which version you are using. Java RA, a utility developed by Paul McLean and Fred DeVries at RA Products to find and remove older versions of Java, now distributed by Singular Labs.